Okay, so we're going to be finishing our notes. What you need to do is find somebody who has a graphing calculator if you don't have one. Pair up. I do have mine here, so I guess you could follow along here if you wanted. But the idea is I want you guys to practice typing the stuff in. So if you don't have a graphing calculator and there's no one else who's ready to start at this point, just follow along with mine. But again, you guys, you need a graphing calculator. You definitely need a calculator for this chapter though. Okay, so we talked about yesterday that if you are given a function and we entered that into the graphing calculator, we looked at the table, wrote those points down, graphed them, and then we started changing the function. We started transforming it. We added 3 to it, and then we took away 4 from it. That when we added 3 to it, it moved it up 3, and we subtracted 4 from it, it moved it down 4. And then we saw, once we looked at those points, that that is what happened with the y-coordinates. While the x's all stayed the same, the y-coordinates added 3, added 3, added 3, added 3. Here, subtracted 4, etc. Okay? Oh, by the way, page 122 in your notes, if it's not on there yet. So now we're going to go to the back, and we are going to talk about the next set on the notes. Okay? Hold on one second. I got to grab one. Okay. So here we go. This is a blank one. My other one isn't blank. So what we're going to do is the same idea. We've got 3 graphs. We're going to graph the first one here. We're going to put the values here and the graph here. So turn on your graphing calculators, and you need to go to y equals, clear out any equations that are there. And first we're going to get the absolute value bars. So the easiest way to get that, one way to get the absolute value bars is you press math. Okay? You're going to scroll over to number, and you're going to see ABS. This means absolute value bars. So you're going to select it. And at this point, depending on your operating system, it might look a little different. So mine actually has the absolute value bars. If you have the older operating system, it's going to say ABS in parentheses. So if you have that, you need to now type in the X and close the parentheses. Excuse me. All right, so again, how do you type in the X? You hit this key. And if you have this operating system, just press X. Hit the right arrow to get out. The rest of you should have closed the parentheses. And again, first time we're going to press zoom, and we're going to choose option 6. So we're going to make our table. We are going to use the same. We're going to use these X values here. We're going to use -5. We're going to use -2. We're going to use 0, 2, and 5. So the easiest way to figure out what their y's are is to go to your table. So hit second graph. And so yours won't look like this. I need to get mine into the right setting. This is a different calculator than the one I had there. So I'm going to press second window. You should not need to do this. I'm going to have my table start at 0, and I'm going to have it go up by 1. This is what we did last time. So now I'm going to go back to my table. All right. So using your arrow keys, you can move up and down. So if x is -5, I can see that my y is 5. If x is -2, my y is 2. 0 gives me 0, 2 gives me 2, and 5 gives me 5. So again, all you did is you put -5 in here, and the absolute value of -5 is 5. Put -2 in, the absolute value of -2 is 2. 0 is 0, absolute value of 2 is 2, and the absolute value of 5 is 5. So I'm going to graph these real fast. So I went left 5 and up 5. Then I'm going to go left 2 and up 2. 0, 0, 2, 2, and 5, 5. So pause the video if you need a little bit more time to graph that. I'm going to put arrows and describe the transformation. Well, this is our original one, so at this point there is no transformation that's happening. All right, this time we're going to change our equation, and we're going to put this +2 on the inside of the bars. So last time we put it outside. We actually put it outside, though, of that radical, that check mark. And it does matter if you put it outside or inside. If I had put that +3 and had continued this bar all the way across, this transformation wouldn't have happened. So there's a big difference between the number being outside and inside. And again, on this problem, it's inside the absolute value bars. So go to your equation or your calculator, press y equals, and I think for us and our calculator abilities, I'm just going to clear it out. Again, I'm going to press math. I'm going to go to a number, choose option 1, ABS, and I'm going to type in x, so there's your x plus 2. And then I'm going to hit the right arrow to go out. If you have the newer operating system, the older operating system, when that shows up, type in x plus 2 and then close those parentheses. Okay? We should all be ready to graph, press graph, and we're going to take a look at what plus 2 does. So what I'm going to do, if you guys notice, and I'm just going to, for a comparison, you don't need to do this. So you can see the before and the after. I don't need for you to type this one. The red one was the original one, the one that we've already graphed, and the blue one is the new one. And what I want you guys to see is that it moved left. It moved to the left 2 times. So what we're going to do is we're going to go to our table, and we're going to write these values down. So what is going to stay the same this time are the y values. Okay? And what I want you to see is if y, which we're calling g of x, is this number, what's the x that we got? So let me change my table here a little bit so you can't see all those numbers. All right, so I'm looking, if y is 5, then what was the x that got me there? And that's a 3. And if x is 2, what's the y that got me there? That's a -4. And if x is 0, the y that got me there is -2. And 2, oh, and you know what? I have a couple of these, so I should have put these in a different order. Because I have 2 appearing again. We might have to reorder these numbers. And then the other 5 is a 3 here. Okay, so, sorry, up here. This is what I want. So there's another 5, it's a -7. So sorry, wasn't thinking about this very well. I'm going to change this one, because I want these to go in order, into the -7 that's there. And I'll show you why I'm putting it in this order. So small gets a little bigger, a little bigger, a little bigger, a little bigger. So the idea is it went to the left. But what I want you guys to see on the table is that while the y's are where we're focusing on the y's being the same, the x's added 2, took away 2 actually. So -5 take away 2 is -7. -7, because it went to the left, took away 2 more. 0 went to the left, and it went to the left 2 times, it became -2. Same thing here, 2 take away 2 is 0, and 5 take away 3, or 2 is the 3. So why do I have to take away 2 to get these values instead of adding 2? We'll talk about that in a little bit, because it seems to be the opposite of what we see in here. So anyway, I'm going to graph these. So 5, -7, 1, 2, 3, 4, 5, 6, 7. Here's -4. Here's this one. Here's 0, 2, and 1, 2, 3. Here's 3, 5. So it did transform, it did change, and this was the before, and this is the after. So it went to the left, and I want you to notice that all of these points went to the left too. This was here, but now it's over 2. This one was here, but now it's shifted over 2 more. Okay? So when we go to this one, and you see the -3, we're going to see how that transforms. So I'm going to go to my y equals, and with the x plus 2, if you just scroll over it and change it into -3, you don't have to retype. I just hit the right arrow to get out. So here you go. I just hit graph. And as you can see, the whole thing is moving to the right. So if you kind of take this point as our point that we look at, and let's put it back on there, the original one. Again, you don't need to do this one. This is where it was. This point right here has gone over 3 spots, which means all the points have gone over 3. Okay? So it's going to go to the right 3. And we're going to compare the same y values. It went to the right 3, but up here, it looks like when you see the -3, that minus sign should be going left. But it's going to the right 3, which means 0, this 0 right here, turned into the 3 over here. So what really happened is I added 3. So if I just take these values and I take -5 and I add 3, I should have a -2. If I have a -2 and I add 3, I should have a 1. The 0 adding 3 is this 3. If I have the 2 and add 3, I should have 5. And if I have 5 and add 3, I should have 8. So when I look at my table, I should see these values popping up. So I'm going to find -2, and I've got a 5, and let's see, 1, there's the 2. For 3, there's the 0. 5, I have a 2, like we said we were going to have. There it is. And then for 8, I should have a 5. All right, so I'm going to graph these. So -2, 5. Here's 1, 2. Here's 3, 0. 5, 2, and 8, 5. You know, I'll just kind of estimate where that is, about there. All right, so kind of the idea about the transformations. Let's talk about transformations now. There are 4 main types of transformations. The first one is called a rotation, and it sounds exactly like it means when a figure just rotates, okay, just turns. There's a reflection. So for instance, I have this. If I just flip it over, a reflection is like a flip. Okay, so reflection is a flip. Then you have a translation. So a translation just means if I take something, let's say this paper clip, and I move it left or right and up and down. That's a translation, okay? And then the last one is called a dilation. And a dilation is like this. So I'm going to show you within the picture. I can't do that. So a dilation is like taking a photo and then enlarging it. So you can have your 3x5 photo, or you can have a 4x6 photo. So those are your 4 types. So the transformations that we have fall into 2 categories. There's one that don't change the shape or size, and there's the other one that does change the size, but it doesn't change the shape. So a rigid transformation, I'm going to abbreviate transformation, doesn't change the shape or the size. It's the same shape, it's the same size, it's just in a different spot. Then we have what's called a non-rigid transformation. And that's where it's a different size. It might be bigger or smaller, but it's still the same shape. Okay? So a triangle, it's still the same type of triangle, you just have a bigger version of it. All right, so we're going to talk now specifically about the translation or transformation that we're going to be using in this class.